So, in our previous video, we talked about linear motion. We even described the terms of linear motion. We talked about the three Newton's laws. We talked about law number one, law number two, and law number three. So now we have a question here, as you can see it here. So this question here, a particle of mass moves in the xy plane such that its position vector is r is equal to this, and AP, omega are constants. Show that, this one will show that the particle moves in an ellipse. What means the force acting on the particle is directed towards the origin. So right now, we are going to begin by solving part A. So part A, we need to show that the particle moves in an ellipse. So, but remember, we have the position of the particle as it moves around. So its position, we have that R is equal to, which is this one here, A cos omega T I then plus B sin omega Tj. So this is its position. This is the x component and this is the y component. So from here, we can split it into two. We say that x is equal to a cos omega t I. And also, y is equal to b sin omega t. But we know that in the equation of an ellipse, we always have squares, x squared. So we are going to make this one squared. So when we square everything, here we shall have x squared is equal to a squared cos squared omega t I. When you square this one, it will be y squared is equal to b squared sin squared omega t. So we look for a way of eliminating the cos and sine. You can clearly see that from trigonometry knowledge actually. The cos squared plus sine squared is always 1. That is how we can easily eliminate it. So we divide here by a, here by b. So that we shall have x squared over a squared is equal to cos squared omega t. This one becomes our equation 1. Then here we have y squared over b squared is equal to sin squared t. Then this will be our equation. So now we can add this one and this so that we can eliminate the sine and the cos. So our x squared over a squared plus y squared over b squared is equal to cos squared omega t plus sin squared omega t. But when we add up this, it gives us what? It gives us 1. So that means that in the end, we shall have x squared over a squared plus y squared over b squared equals 1. Of which this, we can go ahead and simplify it. X over a squared plus y over b squared, which is equal to 1. So this is in form of an ellipse. Therefore, we have been able to show that the particle moves in an ellipse. That is it. It's done. Go for part B. Part B. With part B. Part B says, show that the force acting on the particle is directed towards the origin. So we know that this force is equal to ma. So From our position in the question, the position is this. So when we differentiate, we get velocity. When we differentiate again, we get acceleration. So acceleration is equal to dv dt. Now we are differentiating this. So when we differentiate this, you cannot derivative here, omega. So we shall have minus omega squared cos omega t I. Then when we differentiate the cos, we get a minus sign. So it will be minus b omega squared sine omega t j. We can pull out the common factor from this point. So pulling out the common factor, we can see negative is common. We can also see omega squared is common. So it will be into a cos omega t I, then plus b sine omega t j. But we can clearly see that what is in brackets here is the same as this position here. I don't know whether you can see that. So now we can replace this. So it will be equal to minus omega squared r. But what does the question want? The question wants us to show that the force acting on the particle is directed towards the origin. So our force will be equal to ma, which is equal to negative m omega squared then r. M is a constant, omega is also a constant. So this is our force, and this negative shows that the force is acting in the opposite direction, meaning that the force is acting towards